Hi everyone, this is Mr. Brown. We're just going to talk a little bit about linear, quadratic, and cubic polynomials. So a linear polynomial is a polynomial where the exponent of the greatest exponent is 1 in a polynomial. A quadratic is where the highest exponent is 2, and a cubic is where the highest exponent is 3. So some examples of a linear polynomial is where we have something like x plus 7, 2x minus 3. If you take a look, the exponent of x is 1 for both of them. For a quadratic, it's where the highest is x squared. So if we have x squared minus 9, x squared plus 2x plus 1. These are quadratics because the exponent 2 is the highest of x. For a cubic, it's when we have something where the highest exponent is 3. X to the third minus 1. Okay, so now that we know that, let's take a look at different sequences. So how can we tell whether or not whether the sequences have a linear relationship, a quadratic relationship, or a cubic relationship? So let's take a look at this sequence. And a sequence is just a list of numbers, by the way. So if we have a sequence like this, a list of numbers, what we're going to do is we're going to see if the slope between every two are the same. So to do that, we're just going to find our difference here, our first difference. So the distance between 1 and 2, or in other words, 2 minus 1, is just 1. The distance, or 3 minus 2, is 1 as well. 4 minus 3 is 1. 5 minus 4 is 1. And 6 minus 5 is 1. So, because all of these differences are the same, because they're all the same, we have a linear relationship. So now if we have a sequence like this, 1, something like this, we're going to once again check the differences. So 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. All right, so because these numbers are not the same, these differences are not the same, we do not have a linear relationship. So this is non-linear. But we can actually check to see if it's quadratic or if it's even cubic. To check to see if it's quadratic, what we would do is we would take what's called the second difference. So we're going to take the second difference. So this is the first difference. And what we're going to do now is we're going to actually subtract again. So 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. We took the second difference. So basically we're taking a difference a second time. So a second difference. Now because these numbers are the same, this is a quadratic relationship. So let's take a look at another one where we have 1, 8, 27, 64, 125. All right, let's take our first difference to see if it's linear. 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. And 125 minus 64 is 61. Okay, so we took our first difference, and we can see that it is non-linear. All right, let's take our second difference to see if it's a quadratic. So we're going to take our differences again. I have 19 minus 7 is 12. 37 minus 19 is 18. and 61 minus 37 is 24. Okay, so once again, these numbers do not match up. So it's non-quadratic either. All right, we have one more thing to check. We're going to take what's called our third difference. So we're going to do the same procedure. We're going to take 18, subtract 12, we're going to get 6, and we have 24 minus 18 is also 6. So this is the third difference. So, first difference, the blue is the second difference, and the purple is the third. And because these match up, we have a cubic. The way you're most likely going to see a question like this is if they give you a table with x and y, and our x values, let's say, are 0, 1, 2, 3, 4, and 5. And our y values, we have 5, 4, -1, -10, -23, and -40. So what we're going to do is just like we did before. So we're going to look at the y column, the y row, and we are going to make a sequence. Just like that. We're going to list our numbers in a sequence, and we're going to take our difference. So our first difference. So we're checking to see if it's linear. So we're going to do 4 minus 5. We're going to get -1. Then we're going to do -1 minus 4, and we're going to get -5. Then we're going to go -10 minus 1, and we're going to get, -10 minus -1. So we're going to get -9. -23 minus -10, we're going to get -13. And then we're going to do -40 minus -23, which is the same thing as -40 plus 23. And we're going to get -17. All right, so it is not a linear relationship. So then what we're going to do is we're going to see if it forms a quadratic relationship. We're going to do that by taking our second difference. So the difference between all of these. So our second. All right, so we're going to do -5 minus -1, which is the same thing as -5 plus 1, and I get -4. I'm going to do -9 minus -5, which is the same thing as -9 plus 5, which is -4. We're going to do -13 minus -9, which is -13 plus 9, which is -4. And then we're going to do -17 minus -13, which is the same thing as -17 plus 13, which is -4. So, clearly here, these numbers are all the same. We took our second difference. The second difference is the same. So what kind of a relationship do we have? Quadratic.